This edition of the Impact Podcast is brought to you by ERI. ERI has a mission to protect people, the planet, and your privacy, and is the largest fully integrated IT and electronics asset disposition provider and cybersecurity-focused hardware destruction company in the United States, and maybe even the world. For more information on how ERI can help your business properly dispose of outdated electronic hardware devices, please visit eridirect.com. Welcome to another edition of the Impact Podcast. I'm John Shegerian, and I'm so honored to have with us today my good friend Ajay Kochhar. He is the president, CEO, and co-founder of Li-Cycle. They're doing really important things with lithium-ion batteries in the recycling space. But I just want to introduce you to Ajay Kochhar.
Awesome. Hey, John. Great to be here.
Hey, it's an honor to have you today. And I know you and I are still living under this, the tragic circumstances of COVID-19. You're up in Canada today. I'm here in Fresno, California. But I feel like we're literally in the same room. We had a great offline conversation before starting this interview, and it's just really an honor to have you on with us today, Ajay.
My pleasure, John. I'm looking forward to telling our story and what we're up to, and our worlds, obviously overlap quite a bit. So looking forward to the conversation.
Hey, before we get talking about your company, and for our listeners out there that want to find Ajay's company, you could go to li-cycle.com. There's a ton of information on it, and it will give you a deeper dive into the importance of lithium battery recycling and why we need to do that for the planet's sake and for all of our sakes. Ajay, go a little bit into your background first. How you even got here. You and Tim created this wonderful company. Share for our listeners and our viewers out there your journey.
Yeah, happy to, John. And it really segues well into Li-Cycle's focus. So, myself and Tim Johnston, who John just referred to, were the two co-founders of Li-Cycle. We actually are both engineers by background. So I'm a chemical engineer, Tim's a mechanical engineer and a CFA. And we spent our careers before this in really the chemical industry that produces lithium, nickel, cobalt that go into lithium-ion batteries. So everything from our devices all the way up to, of course, now the exciting segment that people all know about, electric vehicles and much more. So been very battery focused for a long time. And while we were in this space, we were building large projects, executing on these chemical plants, early stage to building them to when they get commissioned and then operate. We would often get asked by our clients and our partners, hey, what's going to happen to all these batteries that we're helping supply materials to, is the one part of the question. And the other part, which a lot of folks sometimes may not know, is, hey, a battery, any of these technologies, they're pretty complicated. You have a whole range of materials in them. They're highly refined, and it's the culmination of a very long supply chain that gets there. And the question is, what's the role of recycled material? You look at some very mature commodities in industries like aluminum and copper, that has continued to be innovated in and really improved. And of course, John, well, but in the cases of materials like lithium, nickel in a battery sense, and cobalt in a battery sense, there hasn't been as much innovation to get back that material into the battery again. So that's really what got Tim and I on the track. We started reading a lot about this space, and what was unsatisfactory to us is, back to first principles, when you look at what's in a battery, it's highly refined material, right? This is the culminating output of a big supply chain and a lot of very complicated processes. But when you try to then re-extract the materials from that, well, then what's the best way to do it? What we were finding in the market is it was just so common to see these thermal processing approaches dominating the market. And for us, coming back to first principles, where does pyro just means high temperature, processing. Okay. Where does that come from? It comes from mining. And, when you take stuff out of the earth, sometimes it's too expensive to start trying to chemically process it. So in the mining industry, they use pyrometallurgy to really just make things easier and cheaper to process. You convert the form. But in the case of a lithium-ion battery, you don't need to do that. It's already highly refined. It's very amenable to very different processing. So that was our story. It was basically born, like many entrepreneurial stories, out of frustration and dissatisfaction, but a desire to make a change. And we left our careers to start Lifecycle.
Were you already long-time, lifelong friends, or you met along the way? When did you guys first meet?
So I've known Tim now for almost 10 years. And I met actually Tim on, I think it was one of the early second, third lithium projects I worked on, the large lithium project in Europe. I was developing the project execution plan. Tim is actually from Australia, from Brisbane. And that's actually where the lithium practice of the company we were was headed up. So we started interacting a lot on that project. And then it just so happens at the same time in our careers, we made a shift a little bit from engineering to management consulting or advisory, still in the same company. But that was very different. You know, on the one hand, initially we were executing these big projects and it's really driven towards a capital cost and building the project. On the advisory side, it was completely different. We would get asked by, investors, corporates, looking at the lithium space or battery space, and they'd say, hey, you folks are the experts, and we're looking at this investment, or we're trying to figure out opportunities, help us here type of thing, and do a review. So that was great, because I think sometimes engineers, obviously engineers are in all walks of life. Sometimes though, when you get stuck in a engineering company, you get very pigeonholed on cost. So you're really focused on capital cost, operating cost, but you sometimes can forget the business case, the business model. What is going to make this business tick? So Tim and I happened to join that group at the same time, worked even more closely together, and ended up actually advising a lot of the lithium companies around the world. And then we both had this entrepreneurial tick, right? This entrepreneurial flair. We wanted to do something, and I knew I wanted to do something, but the question was what? And this was the combination of that acumen, passion for something which we knew needed a solution. And then you take a leap of faith, as you know, John.
And when was that leap of faith? Like, what year was it? What month was it?
That was late 2016. That was late 2016.
And you said, let's do this together.
That's right. So it was literally Tim and Ajay in a coffee shop. We had this idea, we hadn't developed any technology, but we just knew it was a big issue. And we said, you know what, we can't do that here because this isn't this business. Right. Let's do this. So, let's take a leap of faith. So I resigned. Tim resigned around the same time. We got developing, and then Lifecycle scaled from there. And happy to walk through the story, but that's kind of the origin story of the company.
That's just so wonderful. We have so many entrepreneurs from around the world that watch this. How did you figure out, though, as you said, the business case? You're an engineer, so you know that lithium-ion batteries are a problem for, they're now basically ubiquitous to electronics. And when did you realize with Tim now, late 16, now you start marching forward, you're writing a business plan, you're starting to raise some seed capital, I take it. When do you realize, though, that you have something on your hands that's really going to get to potentially is not only going to fix a big void in the marketplace and a big problem in the world, because it is a huge problem. The magnitude of the moment is big, but making it a business, as you and I know, is a whole different story. When did you really feel like, when were you and Tim looking at each other and say, we got this? How long did it take post starting to when you looked at each other and say, we got this?
Yeah, and John, it's all about execution, right? I mean, you can have a great idea and then it's down to execution. So for us, it was probably, at the initial phases, whenever we have take a step back, this isn't, like writing software. And hey, that's a lot of problems in our world need that approach. But this is about something hard tech, real. You got to test it. You got to scale it. You need capital. So as soon as you enter into that regime, number one, it's already harder, right? You got to figure out a way, and it's a little circular, right? You have to show the solution, the traction, and that also begets more traction. But if you can't escape out of that, then you kind of get stuck there, right? So where we knew that we had something was after we'd spent that initial time to validate the technology and the associated economics. Now, coming back to our background, this is why it was so helpful. We had a very structured way of thinking about that. And I'm always a fan, any problem, this is a massive problem, but as you say, it's a very different thing than to create a business out of it. Sometimes it's a bit of a misnomer, young company growing, you don't have any structure. Actually, if you can bring in structure to vague problems and make decisions out of structure, and you have to be nimble and flexible.
Right.
But if you can take that approach, you get to the point where you can say, okay, yeah, go, no go. We think we have something here, or maybe you don't.
It's really
And you
true.
have to be honest. That's hard.
And you're so right, Ajay, because so many people see a problem, come up with a solution, but as you said, there's no business case around it to make it commercializable and scalable. And so you're saying because of your engineering background and Tim's engineering background, you were structured in that approach that when you got to the solution, you also knew the scalability of it.
Exactly.
That's wonderful.
Exactly.
That's
really and that often boils down, like very mechanically, practically speaking, like in our space, what is it? Well, it's a financial model. You got to start looking at, and that's getting hyper specific, but that's the business case. It's the culmination of saying, okay, I got these variables. Oh, we can make money here, or we spend money here, and it has to net be black and positive. And you got to early on start iterating on that. And as you start scaling up, making things grow, validating, there's feedback points, right? So in our technology, this mechanical, chemical, and as you scale up, you get things like recoveries. How much of the material are you recovering? Well, recovery is a huge driver if you can make money or not. So these are the types of things along the way. It's iterative, but you got to have some way to channel that and make decisions and understand, and then iterate more as you continue to go along the path. And as I said, if the answer sometimes is not good, which for some cases isn't, some materials, some industries, within the recycling subset,
right?
It may not make sense in some cases. You got to be honest with yourself about that. And
for our viewers and listeners who just joined us, we've got Ajay Kochhar with us today. He's the president, CEO, and co-founder of Li-Cycle. To find Li-Cycle, Ajay and his colleagues, and the important and great work they're doing, go to www.li-cycle.com. Ajay, just like we know with electronic waste, which is still the fastest growing solid waste stream in the world, and it should not go to landfills because of the arsenic, beryllium, lead, cadmium, and all the other potential hazardous materials that could get into our ecosystem. Lithium-ion batteries are now part and parcel, ubiquitous to the electronic waste problem in many ways, and also the EV car explosion that we've now lived through and are going to continue to see in the next 10 years. Explain the environmental risks and problems with the misallocation or appropriation of lithium-ion batteries if they don't go to a responsible recycler like you.
It's a great question, John, because the first question needs to be, do we actually need to recycle this? Like, what is the benefit, or conversely,
right.
We don't,
right?
So, okay, so in the case of lithium-ion batteries, everyone will know from all the media headlines, sometimes they have risk involved. Okay?
Right.
There's thermal risk, there's electrical risk. This is not a piece of scrap metal. Not only do you have metals like cobalt, nickel that are heavy metals and can go into our environment. That's one aspect of it. But batteries can have thermal risk, if I use the industry term. And I don't need to cite specific examples that people know about, right? So that kind of then begets, okay, well, you can't throw it in the trash, because you throw it in the trash, what's going to happen? And this, by the way, has been happening all around the world. What happens to the battery when it goes through your general recycling stream in a device, even like our phones these days, the battery is embedded in there, right? So a lot of folks don't know. And what's happening all around the world is you have these generalized material recovery facilities, MRFs as they're called, having this fire epidemic, because what happens there, batteries in the device get compacted, they short circuit, it catches on fire. What's all around it is fuel. Right? It's plastic and paper and other things, right? So that then means we can't be throwing these things in the general waste stream. That's the one side of it.
Wow.
The other side of it is, and this is where, back to what I was talking about, the business case, there's a lot of great materials in there. There's fantastic, refined, critical materials in there. What's a critical material? It's something which for our economy and the world is really important and foundational. And lithium, nickel, cobalt, as an example, which are all in lithium-ion batteries, or that range of them, are all critical materials. So we would be remiss if we don't tap into this great urban mining source, to really fuel the future of the world, which is powered ubiquitously by lithium-ion batteries. So it's an environmental imperative, but it's also an economic and a supply chain imperative.
So you're saying the nickel, the cobalt, and the lithium ion that you'll be able to recover from your process will then go back for beneficial reuse to the manufacturers of the lithium ion batteries again.
Exactly.
Wow.
Exactly.
And
Exactly.
close this whole circular economy will
And
close.
exactly. And the challenge and what's been happening, to double click on that, okay,
Mm,
what's been happening to batteries,
mm,
you have different form factors, right? Lithium ion battery, this family of battery type, is
yeah.
in phones, devices, EVs, etc. Different chemistries. There's many, many different types. But what's been happening predominantly, if these batteries get back to a recycling supply chain, it's highly disaggregated, multi-party involved. It's very common that you've had brokers involved along the way. And when they do end up at facilities, it's usually highly manual. At the front end, imagine like an EV battery, even like a Tesla Model S battery. The common thing, and I've seen it with my own eyes, is groups will take apart that large battery pack. And I don't know if a lot of folks know, but in there, there's thousands of little battery cells, and
Right.
they'll literally isolate those up front. Then they often discharge them. Then they try to shred them potentially. And then the biggest issue with the way this has been happening before us is it's been very thermal. There's a lot of thermal processing where people are trying to burn off what they don't want. So they don't want plastic. They don't want some of the solvent in the battery, the electrolyte. I'm not going to get technical, but there's things in there that just people have said, okay, well, this is more like a waste approach. And they're really been after things like cobalt. But as you think about our world and you think about where lithium ion batteries are powering us going forward, how can that be the way? Number one, right? It doesn't sound very fit sustainably that you're burning off things in a
Right.
battery in terms of our future. One,
Right.
two, and by the way, the reason for that is you create a lot of potential toxic emissions specifically from a
Right.
lithium battery when you do that.
Right.
Two is back to your point. Okay, well, then why do this? Okay, we can't put in the general waste stream. We want to get back to materials. So what's a more efficient way that doesn't have a negative environmental impact, but boosts material recovery, which by the way is also better for the economics and the profitability? That's what Lifecycle's been innovated around. And that's where our spoke and hub model comes from.
And let's talk
That's
about
exactly
that.
what we do.
Without giving away your secret sauce, what was the innovative process that you and Tim created that is proprietary? And without giving away that secret sauce, like I said, explain what your solution is as opposed to the old solutions which you're about to disrupt.
Exactly. And this is exactly where Lifecycle is focused. So it's a spoke and a hub model, which is a model used in many industries. In our context, what does that mean? It's a mechanical and it's a wet chemistry, or the industry term for that is hydrometallurgy.
Okay.
People can come across that way to deal with any lithium ion battery. So we don't care if it's from a device, we don't care if it's from an electric vehicle, energy storage, we're totally agnostic. The two steps of what we do and the innovation around it, I'm going to break it into the spoke and the hub, and I'll talk about how we got here.
Okay.
We have two commercially operating spokes today. We have one in Kingston, Ontario, Canada. We have one in Rochester, New York. And those are two existing commercial facilities, and we're building more. What these facilities do is we take in, as I mentioned, single stream, any lithium ion battery, and it's mechanical. We're shredding. But the IP and the secret sauce, not giving anything away, is all around safety.
Oh.
I mentioned this whole concept of safety. As you throw devices into the general waste stream, you have issues with fires. This is what needs to be managed really, really carefully. And our way of dealing with the battery, automated, mechanically breaking it apart, make sure that there's no risk from a safety standpoint in terms of thermal events.
Wow.
So we have a very specific way we do that. It's patented. The IP is owned by Lifecycle. We fully developed it, and it's now commercial. And we're in the stage of basically building that out. Okay, so what do you get out when you basically finish the spoke process? You get three things. You get something called black mass in the industry. It's a very creative name. All it is basically the cathode anode in the battery, the positive negative terminal. Why is it called black mass? It's a black powder. That's
okay.
But that's really the main value. The cobalt, the nickel, the lithium, it's in that black powdery material called black mass.
So all three of those items that you're going to sell for beneficial reuse are contained in that black mass.
You got it. And that's about typically 40% of the mass of the battery coming in. So you've taken away a lot of the mass to get to that most valuable portion. Then you have a plastic stream. And this is where, again, traditionally it's been burned off. It's challenging. Plastics recycling is another huge challenge of our generation. In our case, we've managed to find at least a home back to plastics to fuel. So it can go back into fuel, at least some application downstream of us. And third, there's a metal stream, copper, aluminum, steel, et cetera. that can also be re-recovered for the metal value. So those are the three streams out of our spoke. There's no wastewater. There's nothing thermal. We don't burn anything off, and it's purely automated. And one last point on the spoke plants, and then I'll pause. These are modular build. We basically build them in shipping containers almost, a little bit bigger than that.
Right.
So we can turn these out within 6 months. And this is our vision, that we want to have not 2, we want to have 20 in the next 5 years. Get them close to where batteries are so we can limit the shipping distance for batteries to go from point A to point B. And you get into this valuable intermediate material, the black mass, and you will make this industry much more scalable, much more sustainable, and much more enabling for where our world's going. So more on the hub to come, but I'll pause there if there's any questions.
No, that's great. Let's work it backwards. So on the logistics side, you save a lot of carbon footprint, number one, on your hub and spoke approach in terms of being able to be closer to where the sources are.
Exactly.
Also, it's a safety issue because, as we know, when lithium-ion batteries are being transferred, there's DOT regulations, both on a countrywide basis and on an international basis, which are very stringent because of the danger that lies within in shipping these potentially thermal products. So you're also making it a safer planet, besides also reducing the carbon footprint. Let's go back to the black mass issue. That's fascinating to me. And that's a term of art. I'm sure that's going to get much more popularized as things happen and your company continues to grow and your brand becomes a household name. So comparatively speaking to the old process that existed and how much went to waste and how much went to beneficial reuse, just on a 30,000 foot macro level, the old process, how much of the lithium ion battery went to waste and how much went to beneficial reuse? And now your process, how does that break down? That's what's, to me, where so much of the exciting part of your company and your technology really lies.
Exactly, John. And this does relate, and I'll answer the question at a summary level. It does relate to the hub where we take in the black mass, then we go back to the chemicals.
Yeah.
So end to end, we're enabling 95% recoveries.
Whoa.
Beneficial reuse of what's in a lithium-ion battery.
Oh.
How do you get there? You don't burn things off. That's the starting point, right? And then there's the complexity and the technology. Okay, how do you actually manage all this? The existing way, if you trace the supply chain, you look within a lithium-ion battery, the summary answer is about 50% typically of what's in a battery that gets lost. So it's only 50%, and that might be a pretty generous estimate of what actually can go back to the economy. Now, why? What's happening in those processes? Well, and also what's in the battery? You have graphite, which is on the anode side, it's carbon, basically. In those processes, that's burned off. So that's typically 20, 25% of the battery up to that level.
Okay.
So you already took a 25% hit. You got plastics, which is 5, 10%, depending on the mix. That often is also burned off and not actually separated to go back to the economy, right? You have lithium, which along the way there, it's light, so it ends up going in a waste stream, which is a few percent. Start adding these things up, and you quickly get to 50% of the battery, which you can't recover. Why? Because it's been burned off. And so that's the 30,000 foot answer level. You know, we're taking a very different
5% delta in pickup with your technology versus historical legacy technologies.
Exactly.
Wow.
Exactly.
That's a huge delta.
And I think the last thing which relates to the hub is, we're taking that black mass, we go back to battery grade chemicals. And I think for some people, they might think, oh, it's just nickel and cobalt commodities. These are actually very tailored chemicals that need to meet a specific spec, a specific specification.
Right.
What we're also enabling is actually that black mass. So people might have got there originally, maybe doing something thermal. That then would be directed typically to these nickel smelters, where that's not only what they're set up to take, but they're taking it because it has added nickel in it and cobalt. And then eventually they go back to things that don't even go back to the battery industry. They might go back to a nickel metal, cobalt metal. So we're going back to products which have beneficial reuse directly in the battery industry again. So basically, it's collapsing the supply chain. And instead of having 8 steps, you have 2. That's the big efficiency win.
And I assume the battery recyclers are excited because then they're going to be able to turn back to their constituents and client base and say, hey, we're making our new lithium-ion batteries out of this much recycled material, which is very exciting because they know their constituents, Gen Z, millennials, are all excited about making the world a cleaner, better place and closing the circular economy.
Exactly. And this is now, if I were to take a step back, think about the big mega trend drivers in our world, right? There's probably a few key ones that we're right at the intersection of, right?
Right.
There's electrification,
right?
EV, which use lithium-ion batteries. There's a push for ESG. We are in a time, as you said, John, and you know it so well. And third, which hits on that point, these critical materials,
yes,
lithium, nickel, cobalt, which are the things that actually are going to drive our future.
Right.
There's a big focus in the supply base. So back to your point, for say a battery manufacturer, auto manufacturer, this ticks off multiple things for them for solutions. It reduces the greenhouse gas footprint of the vehicle because we actually are a lower greenhouse gas footprint producer of these materials relative to mining.
Wow.
2, it gives them security of supply. A lot of these materials come from far reaches of the earth, right? Congo is a 70-75% supply of cobalt. This is a huge heartburn issue for a lot of the brands of the world. And why? Because that actually has been tied to child labor, unfortunately. So there's a big push away to find different sources of these materials. And third, it's cheaper. We can be a cheaper source, which can drive down the actual cost of electric vehicle battery for a device, and hence the actual cost of that product to a consumer. So that's why a consumer should care, because this is going to be net, much better for the planet, people, and for the sustainability economic.
Everybody wins.
Exactly. And that's the triple bottom line. That's the triple bottom line.
For our listeners and our viewers that have just joined us, we're so excited. We have Ajay Kochhar. He is the president, CEO, and co-founder of Li-Cycle. To find Ajay and his important technologies, please go to www.li-cycle.com. It's a great website. I'm on it now. There's a great video of him and Tim explaining their technologies, and Tim is his co-founder, and explaining the magnitude of the moment and the importance of responsible lithium-ion battery recycling. Ajay, talk a little bit about your vision. You've been doing this now almost 5 years. You're already open in Canada. You're opening in New York in the near future, in Rochester. How big could this be? How do you dream about this when you go to bed at night? And what's your and Tim's vision the next 5 years ahead?
That's a great question, John. So big picture, okay, our world is going in this direction. And I think a lot of people focus on electric vehicles, but hey, lithium-ion batteries are everything. I mean, I'm always astounded, with our team, our commercial team that helps interface with customers, just the range of applications, marine, lawnmowers, I mean, name it, right? It's mind-boggling, right? So that's something to always remember, right? For the scale and the magnitude of this problem, for sure, EVs and battery manufacturing are the big segments. There's a lot more. And so as we think about where the world is going, we see, try to give you some numbers and how we see our scale growing with that. Today, we're probably in the world about a couple 100,000 tons of lithium-ion battery waste being generated and available for recycling every year. So to give the listeners some context around that, that's maybe equivalent to about 1 million Tesla Model 3 batteries equivalent. It's not all Tesla Model 3 batteries, but it's starting to get up there in terms of the quantity.
Right.
That's this year. 2030, there's a range of estimates out there, and looking at them, but all of them range between 1 million and up to 5 million tons of lithium-ion battery waste or batteries for recycling by 2030. So that is huge growth. And to give you an idea, in our world today, China has a large potential capacity that's growing for recycling, but it's a little hard sometimes to parse what's there today versus the future. But we're probably today at about 100,000 tons, 150,000 tons of capacity for recycling. So already we're way under capacity relative to 500,000 tons. And you think about 1 million to 5 million, oh my gosh, we have a long way to go. And by the way, we are right now the largest, commercial lithium-ion battery recycler in North America. We have 2 facilities. They do 10,000 tons. So that's, big for North America, but based on the numbers I just gave you, there's a huge potential and need here. So what's our vision?
Yeah.
We have 2 existing spokes. We have a hub that's in late stage development in New York State as well. We want to deploy at least 4 hubs and 20 spokes around the world in the next 5 years globally between Europe, Asia, North America, and meeting this need locally, but also from the hub perspective, making those chemicals to go back to lithium-ion batteries again. And that's our vision for the next 5 years. I'm sure we're a little low on those numbers, and I'm always surprised at the upside, but this is a problem that needs solutions, and it takes time. It takes time to do R&D, develop, get to the point where we are as a commercial company now with that kind of behind us. Now we need to deploy. We need to build. Lifecycle needs to now go out and build.
So really, what you're saying is, John, even though you've been at this 5 years, this is really still the top of the first inning. And there's so much further to go nationally, internationally. The problem is only going to continue to grow, and the opportunity is wildly huge.
Exactly. And I think one thing, just for listeners to help understand, I think sometimes people think, electric vehicles are hitting the road now. It's going to be 10 years before there's any, sort of volume, if that's the biggest segment. One thing everyone needs to keep in mind is as you make all these new batteries, because battery manufacturing is trying to grow exponentially, there's also actually production waste, which is 5 to 10% of the amount of batteries made, which, by the way, ends up being a couple 100,000 tons. So that's the near-term reality, that in the near term, you have this source of manufacturing scrap, consumer electronics, and EVs starting to grow. In the future, 5-10 years from now, it's only going to get bigger as we have more and more of these end-of-life cycle materials and batteries coming out too. So that's a little bit of a nuance that sometimes, again, to the general public may not be front page news, if you will.
Ajay, you've given a great story and an opportunity, and I applaud you and Tim, and I cheer you both on what you're doing. Changing the world is not easy. Changing people's mindset, disrupting old industries is not for the faint of heart. You and I know that. And there's lots of naysayers along the way, people sticking out their legs trying to trip you up. As you look back now, just on the last 5 years, and I know you've got so much runway to go and you're going to be massively successful, I have zero doubt. We have a lot of viewers and listeners that are entrepreneurs that want to really be you and Tim next. They want to change the world. They want to make the world a better place. They just don't want to make a profit, which we know there's no shame in saying that, but they want to be disruptive in a good way and make a difference while they're making a profit. Any last words of wisdom for the next generations coming up behind you of entrepreneurs, ecopreneurs that really want to make the world a better place like you're doing?
Yeah, I'm gonna relate a few pearls of quasi wisdom. I'm not wise yet.
Thank you.
I think I'll just sell it to two. I think one, early stage, if anybody is ever, you have a great idea and you're kind of on the fence about taking that leap of faith. I really encourage, you run it to ground, really get convinced about it. But then there's going to be a moment there early on, and it's kind of point one, where you're going to have to dig into it. And if that's what you want to do, that's what you got to do. And it's not for everyone, right? Not everyone has the personal life where they can do that. And you got to think about that. But once you do, also know that in those early couple of months, even 6 months, whatever it is, that's a pretty tough period. So you got to be resilient. I think all through all that. And the path isn't always clear, but you just got to start moving in the direction, start taking in different inputs. You got to be dynamic, and you have to be nimble, and then figure out the way forward, right? So that's, I think, point one.
Great.
I think two is, and this, I'd be remiss not to say, it's all about team, right? I mean, early on, this comes a little bit to the early stage point. Early on, it may just be maybe you and your founder or founders, right? So there's a bit of a chicken and egg problem, right? You need to start getting going, maybe to get funding to build the team, and then the team's going to help you get there. What we did early on, and it's been immensely helpful, is try to get an advisory board. It'll eventually form into an actual board, even if they're just folks that are there guiding, helping, adding value in areas that you may not know. It's immensely helpful. And down the road, we have a lot of those folks that were with us early days. They're still there and adding a lot of value. But I just say that's another tough part. Just talking to some of the practical challenges. People, you need the funding to build the team. Well, the way around that is you can kind of stepwise it a little bit. Get some senior folks that can advise. Eventually, they may become the board, and you can figure out those areas by maybe last point. I'll throw in a third. Is just you gotta no matter what's happening, and we're at a very exciting phase in our growth, but as you said, John, it's really like day one. We've really prided ourselves on, check the ego at the door. I don't know a lot of what's happening in our business. I don't have the answers for everything, right? But I know what we know and we don't know. And I know that we need to bring people together that have those skill sets to really be the driver of success and execution. So I think if you have that mindset throughout, whether it's day one, day from, the first day of the 5th year, 10-year, whatever it is,
Right.
it will continue to have that growth mindset. And I think that's the only way you can really tackle these growth industries that are so dynamic. So I know I threw in a third one there.
I love it. I love it. Those are great. And those are so important. And, all those pearls of wisdom are very usable by the next generation. And I'm grateful for that. I'm grateful for you, Ajay, because I know it's not easy to disrupt old industries and legacy industries. Other people, other firms have a lot at stake. You're doing great work. I'm going to be cheering you on in the years to come and rooting for you. You're always welcome back on the Impact Podcast. For our listeners out there, to find Ajay Kochhar, his partner Tim, go to www.licycle.com, li-cycle.com. Ajay, thank you for making such important impacts on this planet. Thank you for making the world a better place. And I just wish you continued success. And I'm rooting you on to become a ubiquitous name around the world.
Thank you, John. It's been a great pleasure, and looking forward to us, overlapping as well in our worlds. They're pretty close. We didn't get into that, but that's maybe for another episode.
Another episode. And you're always welcome back to continue to share your great story at Li-Cycle.
Thanks, John. I appreciate it.
Take care. This edition of the Impact Podcast is brought to you by Trajectory Energy Partners. Trajectory Energy Partners brings together landowners, electricity users, and communities to develop solar energy projects with strong local support. For more information on how Trajectory is leading the solar revolution, please visit trajectoryenergy.com.